Welcome back to the Universal Timeline. We are continuing our journey through the earliest moments of existence in the complete history of the universe. This is episode 03 of 30. In our previous episode, we explored the Grand Unified Epoch where the fundamental forces began to separate. Now we move forward in time, but only by the tiniest fraction of a second. We are situated roughly 1 picosecond after the Big Bang. The universe is no longer a singularity, but it is still an incredibly hot and dense cauldron of energy. At this stage, the universe is filled with a soup of fundamental particles including quarks and leptons. However, a deadly symmetry exists within this cosmic soup. For every particle of matter that was created, there was also a particle of antimatter. This is the fundamental law of pair production that dictates energy creates matter, and antimatter in equal parts. Antimatter is identical to regular matter in mass but possesses an opposite electrical charge. An electron has a negative charge while its antimatter counterpart, the positron, has a positive charge. When a particle meets its antiparticle, they destroy each other instantly. This process is known as annihilation. The result of this collision is the complete conversion of their mass back into pure energy in the form of photons. If the laws of physics were perfectly symmetrical, the story of the universe would have ended right here. Matter and antimatter would have emerged from the energy of the Big Bang in perfect 1-to-1 ratios. They would have instantly collided and annihilated one another entirely. The universe would have been left as nothing but a vast empty sea of radiation. There would be no stars and no galaxies. There would be no planets and certainly no life to observe it. Yet we look around us and we see a universe filled with matter. We see vast clouds of hydrogen gas and solid planets made of rock and metal. We do not see distinct regions of antimatter interacting with our galaxy. This observation leads to one of the most profound problems in cosmology. This is known as the Baryon Asymmetry problem. Somewhere in those first few moments, the perfect symmetry was broken. As we delve deeper into episode 03 of 30 on the Universal Timeline, we must understand the scale of this battle. The universe was expanding and cooling rapidly during this epoch. As the temperature dropped below critical thresholds, the creation of new particle pairs slowed down. However, the annihilation process continued relentlessly. Quarks and anti-quarks smashed into one another, returning their mass to the energy field. Cosmologists calculate that this war of annihilation was incredibly efficient. Imagine a battlefield where billions of soldiers stand on each side. In the early universe, there were roughly 1,000,001,000 particles of matter. For every 1,000,000,000 particles of antimatter. This slight imbalance is the only reason we exist today. For every billion pairs that annihilated each other, leaving nothing but light behind, a single particle of matter survived. That surviving 1/1000,000th fraction constitutes all the matter we see. In the observable universe today, every star in the night sky and every atom in your body is a relic of that survivor. The energy released by the billions that died is still with us as well. It has stretched and cooled over 13.8 billion years to become the cosmic microwave background radiation. The question remains regarding what caused this life-saving asymmetry. Physicists refer to the necessary conditions for this imbalance as the Sakharov conditions. One key requirement is a phenomenon called CP violation. This stands for charge parity violation. In the mid-20th century, experiments demonstrated that the decay of certain particles does not treat matter and antimatter exactly the same. Neutral kaons were observed to decay in ways that favored matter slightly over antimatter. This suggests the laws of physics are not perfectly mirrored when you reverse charge and spatial coordinates. While the CP violation we have observed in laboratories is small, it proves a fundamental principle. Nature has a slight preference for matter. This preference was amplified in the extreme conditions of the early universe. In the complete history of the universe, this moment is defined as the triumph of matter. We are currently exploring the timeline between 10 to the power of -32 seconds and 1 second after the Big Bang. This covers the electroweak epoch and the quark epoch. During the quark epoch, the universe was filled with a quark gluon plasma. The temperature was too high for quarks to bind together to form protons and neutrons. They moved freely in a state of extreme density. As the universe expanded, it cooled to around 10 trillion degrees Kelvin. At this point, the annihilation of quarks and anti-quarks was largely complete. The tiny surplus of quarks began to stabilize. As we approach the 1 second mark, we enter the Hadron Epoch. The remaining quarks began to bind together under the influence of the strong nuclear force. They formed the first stable hadrons, which are composite particles like protons and neutrons. This was a crucial transition in the complete history of the universe. The building blocks of atomic nuclei were now established. However, the annihilation was not quite finished. Leptons, which include electrons and neutrinos, still existed in thermal equilibrium with photons. The universe was still hot enough to create electron-positron pairs spontaneously. But as the universe reached 1 second in age, the temperature fell below the threshold for creating these pairs. A second Great Annihilation event occurred. Electrons and positrons collided and destroyed each other on a massive scale. Just like the quarks before them, a tiny asymmetry allowed a small fraction of electrons to survive. This left the universe with a balance of protons and electrons that would eventually allow for neutral atoms. The vast energy released by this electron-positron annihilation dumped more heat into the universe. This slightly delayed the cooling process but could not stop the expansion. By the end of this violent period, the composition of the universe was set. It consisted of a sea of photons, neutrinos, and a trace amount of matter. That matter was composed of protons, neutrons, and electrons. Antimatter had been effectively wiped from the visible universe. Today, we can only create antimatter in small amounts in particle accelerators. It immediately vanishes upon contact with the walls of the containment vessel or air molecules. The scarcity of antimatter is the direct result of the events we are discussing in episode 03 of 30. This era defined the material content of the cosmos. Without the Great Annihilation, the universe would be incredibly heavy with matter or entirely empty. Instead, we have a universe dominated by radiation but sprinkled with just enough matter to build complexity. The survival of matter allowed for the eventual influence of gravity. Gravity needs mass to work with. Without the surviving protons and neutrons, gravity would have had nothing to pull together into stars. It is humbling to realize that our existence is based on a statistical anomaly. We are the leftover dust from a cosmic catastrophe. This concept is central to understanding the narrative of the universal timeline. We see that chaos and destruction in the early universe paved the way for order. As the first second of time concluded, the stage was set for the next major act. The protons and neutrons were flying apart at high speeds. They needed to fuse together to create the first atomic nuclei. This process is called nucleosynthesis, and it requires precise temperature windows. If the universe stayed too hot, the nuclei would break apart instantly. If it cooled too fast, the protons and neutrons would never find each other. The expansion rate had to be perfect. In this episode, we have witnessed the universe cleaning the slate. It removed the antimatter that would have prevented the future formation of structure. It locked in the ratio of photons to baryons that we measure today. The density of the universe was dropping rapidly. The fog of particles was beginning to thin out, although the universe remained opaque to light. We are now standing at the threshold of the first minute of time. The intense wars between matter and antimatter are over. The survivors are ready to build the first elements. In the next installment of the complete history of the universe, we will watch the birth of hydrogen and helium. We will see how the first periodic table was constructed in a fusion furnace. Spanning the entire cosmos, this has been episode 03 of 30 on the universal timeline. Thank you for joining us in this exploration of our origins. We will see you in the next epic.